Welcome back, everyone, to the eCoreAcademy e-learning platform today. My name is AJay Raj, back with yet another geometry video for you all. Today's lesson topic is all about triangle proportionality. I know we've been going through a lot of triangle topics, but triangles are very unique. When you're looking at the matter of fact that they are a very unique polygon, they're the basis of polygons. The minimum requirements for side lengths for polygons is, of course, representative through a triangle. And you are going to get to more complex figures such as, hexagons, dodecagons, dodecahedrons, 3D shapes, much more into that. But here in geometry, we're trying to build a strong foundation as you might consider and move on based off of these topics in, say, for example, Algebra 2 and in some calculus references as well. But before I jump into today's lesson, please make sure to smash that subscribe button down below, hit that like button on this video, as well as turning on post notifications by hitting that little bell icon right next to the subscribe button. All three of those things are greatly appreciated. Thank you for doing that. As I was saying, today's lesson topic is all about triangle proportionality, and the central theme of today's lesson is to discover what are the theorems of triangles that represent proportionality, and what are some of its properties. Now, I know we've also referenced to the triangle midsegment theorem. I created that as a separate lesson. You might be thinking, why wasn't it incorporated here? Well, triangle midsegment theorem is a bit more complicated. It has a bit more length and steps to its process. And also, it's not very often included in many geometry courses, and I had included it separately, so I wanted to get you guys acquainted with that and give some isolated focus to it. But today, we're also going to be focusing on other triangle proportionality theorems, specifically for this lesson. So without further ado, let's jump right into it. So, first slide, triangle proportionality theorem. I know we were talking about triangle proportionality, and yes, there's a theorem basically named off of our entire topic for today, the triangle proportionality theorem, and of course, it comes with a given scenario. So this is part one. So let's look at the triangle proportionality. Let's look at triangle proportionality, and then of course move on to the triangle proportionality theorem. So proportions are used to solve problems using the triangle proportionality theorem. Like I said before in my previous video about triangle midsegment theorem, proportions are used in order to develop ratios, which actually show equivalence. It shows relative equivalence between two values. Doesn't mean they are necessarily equivalent, but it shows the level of equivalency that they need. Say, for example, if you're given an apple basket that contains 4 apples inside of it, and then you have another apple basket with 8 apples inside. The way that you're going to reference those two is by creating a ratio of 8 to 4, which basically simplifies to 1 to 2. And what that's stating is one basket has half as many as the other basket, or the basket with 8 has twice as many as the original basket of 4. References as such, that's what you're going to be utilizing. And of course, that plays a major role in our proportionality theorem. The triangle proportionality actually proves that if a line parallel to one side of a triangle intersects the other two sides, then it divides those sides proportionally. So the triangle proportionality theorem is basically what I said before. It's representing some sort of form of proportionality. And doing so, you're actually developing some sort of triangle midsegment here. I know this basically looks the same as our triangle midsegment theorem that I had showed you previously, but there are different ratios and values that are created. So basically what you're doing here is you're developing triangle proportionality by developing a midsegment of this triangle, and that's line DE intersecting the center of this triangle. I just pulled up a diagram here. And this is also known as the side splitting theorem. So it intersects two sides at the center, and then of course it's parallel to the third side. In this case, it's the base BC. So I'll show you exactly what the triangle proportionality theorem looks like here. In an example, what are some of its properties? So let's look at its representation. I'll draw this out for you. So if we're given a regular triangle shown here, so if we're given this triangle here, and we actually create a midsegment of this triangle, let's estimate the midsegment to be approximately here, and it is parallel to this base here. I'll label this A, B, C. Put some endpoints there. And if you're looking at the center, you've discovered the triangle, the midsegment of this triangle. What you're going to do now is you're actually going to develop some sort of ratio here. With this given bottom base here, what you're going to do is you're going to be given all of your side lengths originally. You're going to be given the original side lengths here. So let's start off with a base of 16 and side lengths of I'll make this an 8, 8, and then a 4 and 4. So basically what this theorem does is, actually we don't need the base. Let's not focus on the base. So what this theorem basically represents, proportionality, triangle proportionality, what it represents is the triangle proportionality theorem, which basically states that if there's a mid-segment of a triangle that's developed, and of course that mid-segment has to qualify for specific triangles, in this case it does for triangle ABC. As you can see here, it splits the side, each side into two different segments. This does not necessarily have to be the mid-segment. It just has to connect 2 points on this given side here. So that's the one major difference between the triangle mid-segment theorem and just proving a triangle proportionality through a line intersecting a triangle. It does not have to intersect at the midpoints. As you can see here, these endpoints of this line here are basically splitting the sides of this triangle, the legs of this triangle, and it's splitting it into two different values, 8 and 4, on both sides correspondingly. Now, what the triangle proportionality theorem states is that these new side lengths created, these sides developed, are actually always going to be proportional. Meaning, I'm going to label this as x, 8 as x, your y, and then w and z as reference. So what the triangle proportionality theorem states is that if you look at one side of intersection on this triangle, you have your values 8 and 4 represented by x and y. What you can actually do is you can prove that x over y, or 8 over 4, will always be equivalent to w over z, which is the same, sorry, not w over z, but z over w, same locations, and that'll be 8 over 4, or let's write this here, 8 or 8 over 4, or 8 over 4. And if you see here, 8 over 4 divided 8 divided by 4 is 2, and 8 divided by 4 is 2. Therefore, 2 equals 2. So that's one ratio that works out. So you can divide both sides by each other, keeping those relative positions consistent, and then you always get an equivalent answer. You could also cross multiply between x and w and y and z. So then you would get 8 times 4 equals 32, and 8 times 4 equals 32. And this is always true in any scenario. And finally, you could always multiply between two values on each side, meaning you can do 4 times 8. Sorry about that. You always do 4 times 8 equals 32, and 4 times 8 equals 32. And those are always equivalent. So those are the three formats of the triangle proportionality theorem. Next, let's look at the triangle angle bisector theorem, and this is part 1 for that. So let's look at an angle bisector before we actually move to the properties of the triangle angle bisector theorem. So when a triangle's angle is bisected, a proportion can be made to solve a triangle angle bisector theorem problem. So I'm sure many of you already know what an angle bisector is. It's basically what splits an angle into two and will intersect the opposite side of the triangle given. Always going to be relative location. So we're going to be given a bisector in this case in order to look at the angle bisector theorem, triangle angle bisector theorem. So an angle bisector is a line segment, or ray that divides an angle into two congruent angles by intersecting it. Very simple. If you're looking at this triangle right here, and we're given this angle here, we'll have an angle bisector that'll basically split this angle into two congruent halves. Triangle angle bisector theorem part 2. Let's identify proportionality in this theorem. So the triangle angle bisector theorem states that a segment that bisects the angle of a triangle divides the opposite side into two segments proportional to the other two sides. So what that basically looks like here is, if we're given a triangle here, I'll go into further depth on values in the next slide. But if we're given three. Let's leave our angle of focus right here. So this is the angle that we want to focus on. What it's saying is that if you have your segment or a line segment, a line or array that basically intersects and bisects your one angle of focus, what happens is when it intersects the other side, its opposite side, it's going to extend onwards. If it's a line or line segment or array, it's going to extend onwards. And what it does, in turn, it basically intersects this entire triangle. It seemingly splits it in half in this case, but not always. It'll basically intersect through and intersect the opposite side. And once you're doing that, you're actually going to develop some sort of proportionality between two sides on each side and two sides on opposite sides, similarly to our basically our triangle proportionality line segment that'll intersect two lines. But in this case, we're intersecting an angle and a line, and of course your vertex as well. So I'll show you what that looks like here. So I'll show you what that looks like right here. So if you're looking at this value here, and if we have this intersection here, and say, for example, we're given our value, our side lengths for these two legs of this triangle. Let's assume that these values are going to be 8 and 8. And finally, let's basically assume let's assume that these bases are going to be, that the bases of this triangle is going to be equivalent to 8, and therefore we're splitting it into two equivalent halves, which is 4 and 4. We're going to use the same example here. So in this scenario, this is not always the case, but if it is properly intersected through the angle bisector, these values will correspondingly match up and follow this rule that I'm about to show you. But similar to the previous theorem that we had seen before, what you're basically going to label these as X, Y, W, and Z. And when looking at these values, you can actually develop your proportionality statements. So if we're looking at 4 and 8 on this side, that means that X times Y, or 4 times 8, must be equivalent to W times Z, which is also 4 times 8. And that is true because they both equal 32. They both equal 32. And then, of course, you can do the same thing in division. So you can do Y over X equals Z over Y, which is 8 over 4, equals 8 over 4, which, of course, equals 2. And finally, you can cross multiply. You can do W times Y and Z times X, which is 4 times 8 on different sides, and that's 32. And finally, you can do Z times X, which is 8 times 4, which is 32. And of course, 32 equals 32. All right, now let's look at our part 3 of the triangle angle bisector theorem. And now we're going to look at the converse of the statement. Basically, the inverse statement of this. It's basically when you swap the hypothesis of a statement with its conclusion. So let's look at this statement. So the converse of the triangle angle bisector theorem states that if a ray or segment divides the opposite side of a triangle into segments proportional to the other sides, meaning that you can create those three senses of proportionality: cross multiplication, same side multiplication, and same side division with relative positions. And if you're able to do that with equivalence, then the ray or segment bisects an angle of the triangle. That's basically saying if a line intersects one side of a triangle and it's able to create that proportionality, that means it also intersects one of the opposite angles. So very, very simple. Say, for example, we're not given the angle of focus here, and we're just given that a line, intersects one side and it has proportionality with our X, Y, W, Z ratios. X, Y, W, Z ratios. We can tell that it must bisect one of the angles of the triangle, and it's obvious because it's going to be the opposite triangle of the given intersected side. All right, everyone, I hope you guys enjoyed this video. This has been the eCoreAcademy e-learning platform. Please make sure to like and subscribe, and also turn on post notifications so you don't miss out on any of our latest uploads. Also, please make sure to visit our website at www.ecoreacademy.org. There we have full unlocked access to what we as an educational platform, online educational platform, actually provide for you guys. We have full unlocked access to our integrated note sheets, quizzes, and worksheets that go along with each and every single one of our videos. organized into lessons under organized course studies as well. So there we have extra event information and, of course, our contact information. But if you can't get access to that full contact information, which of course is basically all you have to do is sign up for free and make an account there. If you haven't gotten access to that information, please make sure to email us at eCoreAcademy@gmail.com. We will get back to you as soon as possible if you have any questions, if you just want to reach out to us. And also, finally, please visit all of our socials in the description box below. We take a lot of time to actually upload there as well. So check out what kind of new and different content we have there aside from our website and our YouTube channel. Our platform links are down below, and that's at Facebook, Twitter, and Instagram. So, of course, check us a follow out there and use our medium to share our videos. Once again, everyone, I hope you all enjoyed. This has been AJay Raj, and I will see you guys in the next one. Peace.